Alright, hello everybody. Today we're going to be talking about waves and some wave phenomena that you need to know for Unit 4 Physics. So first, we need to break down the two types of waves. So there are longitudinal waves, in which the disturbance is parallel to the direction of motion. So a sound wave has these regions of high and low pressure that wiggle back and forth in the same direction that the wave is traveling. And then on the other hand, we have transverse waves, where the disturbance is perpendicular to the motion of the wave. So if you think about a cord or a string or something, when you flick one end, you can see how that disturbance travels down the cord. So before we get into analyzing waves, we need to know their components. There will be an amplitude, which is the distance from the mean line to the peak or the trough. Now, something that I should mention is that waves are cyclical, okay? They repeat. The physical distance between two of the same points in a wave, so it could be the two peaks, could be the two troughs, it could be between the two means, but you have to be careful which one you're talking about. So I'm taking the mean on the way up. That would be these two. Or let's take another random point. So about halfway on the way down would be from here to here. And all of these distances are called the wavelength. And we use the Greek letter L, a lambda, in meters. Then we have the period T, which is in seconds. If I took out a stopwatch and I counted, say, between the two peaks, I started it when the wave was over here, and I stopped my stopwatch when the wave got to here. That would be the period in seconds. And if I want to know how many times per second the wave repeats itself, I can take 1 over the period is the frequency, which has a unit of hertz, Hz. And that basically means per second. So if instead of a stopwatch, I had a 1 second timer and I counted every time I noticed a peak in the wave, that would be the frequency. It doesn't have to be the peak. It could be the number of troughs. It could be the number of times that any point on the wave happens in 1 second. Now that we've identified the parts of a wave, we can use our equation, which is that the speed v is the frequency times the wavelength. And because we know that the frequency is 1 over the period, we can make that substitution, and v is also the wavelength over the period. Now, I haven't talked about light yet. Light is a special case where, by virtue of there being an electric field oscillating along one axis, there will be a magnetic field oscillating along the other axis. Now, both of these disturbances are perpendicular to each other, but they're also perpendicular to the direction of the wave's motion, which would be left to right across our screen. And Einstein and James Clerk Maxwell both told us that light moves at the speed c, which is 3 times 10 to the 8 meters per second. What does that mean? Well, if you wanted to go as fast as a light wave, you would have to run back and forth across Australia about 80 times every second to catch up with a light wave. And so, because light always travels at this speed, we can write c equals f lambda equals lambda over t for light waves. The other physics exam checkpoint is that if you're asked to define a wave, you need to say that waves are a transfer of energy with no net transfer of matter. Sometimes they use the example of a dust particle floating back and forth in a sound wave. Well, the dust particle won't get pushed in the direction of the wave. So if a dust particle starts off over here, it won't end up somewhere here due to the wave. It's not a property of waves themselves.